Alright, so what I'm going to do is I'm going to build out that deck of cards assignment really quickly. And I just want to jump back into it so we can look at the requirements of the assignment, just so we know what it is we're building. I need to build a deck class, I need to build a player class. A deck should contain 52 cards, a deck should shuffle, reset, deal a random card, and the deck should return the card that was dealt and remove it from the deck, right? For dealing a random card, I feel like this feature is dependent on the deck being shuffled. If the deck is shuffled, then our card is random, we're happy. And then we also have the player. A player should have a name, a hand, they can take a card, and they can discard a card. And then we also have this optional thing of creating a whole blackjack game, which I can kind of talk about, but let's not build that right now. So in standard ES5 or vanilla JavaScript, we cannot actually use the keyword class. So we're going to create a function called deck, which is our deck function. So one thing we can do with this, which is a pretty common ES5 pattern, was a lot of times we created a variable called deck and stored a function called deck inside of it. Once upon a time, there was no class in JavaScript. So if you were defining a class, you kind of wanted to make that apparent to other developers who were looking at your code. This was one of those design patterns where we create a variable called deck, and inside of it we store a function called deck. When we call deck in this case, so like var deck1 equals a new deck, it is referring to the variable, which then calls the function and invokes it. So this is just a code cleanliness kind of thing where we're saying, I am defining an object constructor. Because there are no classes in ES5. There's just object constructors. But what is a class? It's a function that returns a new object, right? So what did our deck class need? We needed a deck. So we're going to say this dot deck equals an empty deck. And that's how we'll start it. This is the keyword that we use to refer to whatever the object is. It's much like self from Python. In JavaScript, it's just called this, right? So we have this deck, but we also want to build out all of the cards for this deck. So I'm going to create a couple scoped variables. These variables are going to exist inside my constructor here, but after my constructor is done, I want to get rid of them. So they're called var. I don't want somebody to access this suits or this suits array. I don't want somebody to access the pips array outside of these two class definitions, out of this class definition. So I'm attaching them to var and not this. Essentially, just taking advantage of the behavior of JavaScript itself by calling these variables, I'm locking them within this function and they can't escape by those scoping rules we kind of explored on Monday. So under the scoping rules of JavaScript, these variables are never getting out of my constructor, and that's how I want it. I don't want anybody mucking around with them. So let's start our suits. What do we have? Hearts, spades, clubs, and diamonds. And then what are our pips? We'll start with ace, 2, 3, 4, 5, 6, 7, 8, 9, and then 10, and then jack, whoa, queen, king. Beautiful. All right, so we have a for loop that walks through all of our, well, we want to build a for loop that walks through all of our suits, and for each of our suits, we want to walk through each of our pips and start appending them into this .deck. So let's go ahead and do that real quick. I want for suit in suits, and we can actually say var suit here to make sure that we're actually locking this. Notice that it's still allowing me to run the code without the variable keyword. And that's something that I get asked all the time during algorithms. Do we need the var keyword or do we not? And the answer is we don't. But what does it do when I ignore the var keyword? It says it right here, it's making it global. And do I want suit to be accessible outside my object constructor? No. So I'm going to say var suit in suits. So this is going to walk through all of my suits. For var pip in pips, which will walk through all of my pips. So this is for every suit, we have every pip. And we want to just push it. So we're pushing this.deck.push, and this is the craziest line. We need to go in and we need to say pip at pips, so pips at pip plus of suits at suit. Beautiful. So let's go ahead and run this. We'll build our new deck, and then I just want to console log deck1.deck and make sure that I'm getting all of those cards. All right, so I'm getting my entire deck of cards, and it's printing it out. It's sticking it in this deck array. So every single time I run my object constructor, I create a brand new deck of cards and populate it, right? So that's step one. What was step one? Our deck should contain 52 cards. So let's deal with shuffle really quick. And did I even link directly here? Oh, I did. So I don't want to rewrite shuffle. I think it's really important that we have a non-biased shuffle. What non-biased means, if I give you 3 cards to shuffle, I would want you to have just as much chance of giving me those 3 cards back in the same order as any other order. A biased shuffle would say that we're always moving the first element to a new place. But we need to allow it to randomly give us back the same input that we gave it. So a non-biased shuffle means that it is truly shuffling the deck without giving favoritism to any particular output. So the one that's actually driving the randomness is math.random. One thing about how math.random works in JavaScript at a low level is it picks up the seed number from the clock, actually. And it goes into the clock, it goes into date time, it finds some number way deep into the decimal point, it uses that as a seed to generate its random number. So math.random is pretty dang random. You can't really game it by just looking at the clock or any behavior like that. And that's going to take care of all of this random for me. So I'm going to grab this whole shuffle array method and I'm just going to implement it because we want to build a deck of cards. We don't want to have algorithms part 2. So let's just grab that, but we got to integrate it. And there's a lot of things that are wrong with it because it's a standalone function. So what I want to do is I want to add it as a prototype to deck. So I'm going into deck.prototype.shuffle, and I'm going to define this function. Now, what's the input for shuffle? The deck. But does my deck already have access to the deck? It does. So this doesn't take any inputs. I'm modifying the deck I already have in here. Another thing you're noticing is I could have taken this and I could have dropped it inside my class definition, just like this. But there's a problem with putting it here. Missing semicolon. Other than the missing semicolon. There's a problem with putting it in here. By putting this prototype method inside the constructor, that means every time I construct a deck, I am rewriting shuffle and replacing it with exactly what it already was the last time we updated it. There is only one prototype for the entire deck class. If we modify it, it's there. It's ready to go no matter how many instances we create or how many instances have already been created. We can actually take this prototype line and put it way at the bottom of our code, and it's still going to run without complaining. We've attached it to the prototype. So if we put it in our object constructor, we essentially just do a lot of unnecessary work every single time we constructed an object. It's like you bought a car from BMW and they reprinted the manual on top of an old one and handed it to you. It's unnecessary, right? So we're taking this and we're cutting it completely out of the constructor. The constructor is lightweight, and now shuffle exists in only one place in all of our code.
So if you put the function inside the constructor, it would call every time you create an instance, right?
And it would replace itself, because what are we looking right here? What's the big key thing? It's the equal sign. This is an assignment. If we run this every time we construct it, we are just reassigning a function with what it was before. That's totally unnecessary. So we're taking it completely out of it and attaching it to the prototype. The prototype is essentially our deck object has this prototype attribute, right? And all instances will first check themselves and then they'll check the prototype to see if it exists. If it exists within themselves, they'll be happy and they'll run it. If they can't find it there, they'll look for this method, let's say shuffle, in the prototype. A cool thing we can do with prototypes, not to get too distracted here, is I can add a prototype to JavaScript's base classes, right? Let's say array doesn't have something, is missing something we want from it. And I know what's missing from the JavaScript array is array. Arrays always identify themselves as objects in JavaScript, and I hate that. So I can say array.prototype.isArray is a function, and now I've added a new method to every array in my code. I can create a brand new array, var x equals, a 1, 1, 2, 3, right? Now x.isArray is a method that I can call on every single array within my code base. So this is how the base methods, the default methods that are given to us with JavaScript are attached to its default classes. We can modify array, we can modify object, we can modify string. One word of warning, don't replace anything that already exists in the array. If I say array.pop and rewrite pop, that could cause problems that I don't want to happen. So just keep that in mind. We can modify literally any existing class by attaching new stuff to the prototype, but when we're doing that with JavaScript's default classes, we can break our code quite a bit. All right, so back to shuffle. We want to shuffle. Let's get rid of all of this. It's going to get mad at us now. We want to use this shuffle method. So let's kind of rewrite it. We want var m is equal to the array length. No, we want this.deck.length. That's our array, is this.deck. We want to initialize t, we want to initialize I. Just for a note, and this always confused me the first time I saw it, what am I doing in this line? Var m equals this.deck.length, comma t, comma I? What is this actually saying?
M is equal to the deck length?
Yes. What is t? What is I? So, I think the much easier way to understand what we're looking at here is to think of it like this. The thing we're comma separating and making come next to each other is the var keyword. We're basically saying I'm declaring a variable on this line, t is also a variable, I is also a variable. So in the exact same way, I can say var t, semicolon, var I, semicolon, and then make sure we have a semicolon at the end of this. It's the exact same thing. I'm basically declaring a bunch of things in multiple lines. It's worth talking about because you don't see people writing JavaScript that way too often, and if you do, it kind of messes you up the first time you see it. All right, so I'm declaring all of these variables. T and I are both empty, they're both undefined, we're cool with this. We're going to create a quick while loop. As long as we have an array to loop through, we're going to go into I, we're going to floor a random number, random, and multiply it times m minus minus. What was m? The length of the input array. So I roll a random number based off of the length of the input array, then I shrink that length, and then I go ahead and just do a swap. T equals this dot deck at m, this dot deck at m is equal to this dot deck at I, and then finally this dot deck dot I is equal to t, which is our temporary variable. This is a standard swap. T is our temporary. We hold something there. We switch the two elements.
So what does m minus minus mean?
M minus minus, and then return. M minus minus is shrinking the length. So if I have an array that's the length of 50, the first time I roll a random number and swap it around, I lower that number down to 49. So essentially, at the end of my array, I move a random number based off of everything else that exists there. I move back one space, I look at the rest of the array, I move a random number into that space. I go back a space, I move a random number. We can talk about this function afterwards. I think the big thing is it's going to shuffle it for us, and it's going to give us a proper shuffle that doesn't have kind of biases in it. Final thing is I need to return at the end of this. But what do I want to return? This. Why do I want to return this? So I can chain it, right? So if I return this, then I can call new deck dot shuffle dot shuffle. By returning it every time, I can chain my methods together and I can shuffle them together. And we're getting some weird behavior right here that I'm not expecting. We're getting the definition of shuffle. Okay. I was trying to show that it chains it together. Oh, because I'm console logging it. Duh. Okay. All right. So by returning this at the bottom of my function, when I run shuffle, I'm getting back my entire object. I'm getting back the deck. I'm getting back all of the attributes it has and the newly shuffled array. But I'm also getting back all of the methods of that particular deck, right? Because deck it's an object. It contains methods inside of it. If I said return this dot deck, when I call deck1.shuffle, this is now equal to an array, not an object, and that causes problems. I can't keep chaining it together, right? So I'm returning this, and then I can chain it because I'm always getting my object back. All right, so I added my shuffle method. We can shuffle it. Let's just quickly console.log deck1.deck and see if it's properly shuffling me an array of cards, and it is. Every single time I'm getting a brand new array, and those arrays are relatively non-biased, barring the clock. All right, so we also want to be able to reset our deck. What do you think reset does? What does that functionality do? It puts it back in order, and that's my gut instinct. Some people empty the array at this point. I feel like putting it back into order is really what we want. So what I'm going to do is I'm going to create a new one called deck.prototype.reset, which is a function. And I'm going to take all of this logic right here, I'm going to rip it out, and I'm going to put it into reset. Because as far as I'm concerned, this is my reset, right? I build a brand new deck of cards, and I load it in. So what I'm going to do is in my reset, I'm going to say this.deck is equal to an empty array. I'm going to empty out my deck, and then I'm going to return this. Now, in my object constructor, I can literally just call deck this.deck reset. I have to unshuffle it?
Yeah, I need to do
A sorting algorithm?
yeah. It's like the casino just throwing out the deck of cards.
I don't think we would actually get performance out of that. I think we're actually benefiting from throwing away the deck of cards.
Losing money. In the casino. I know what you mean.
I'm really now I'm like stuck and I'm trying to think of like how we could benefit from actually resorting it. If memory was a concern for whatever we were building this on, I would totally reuse that array. But since memory is not a concern and this is being sent to somebody else's computer because it's JavaScript, they can suffer. All right, so my object constructor simplified immensely because now I'm calling its reset method within it, and now it's giving me back that deck that I want. I now have a reset function that could be called multiple times because it's returning this. I have a shuffle function that could be called multiple times because it's returning this. So just to prove that it all works, which I like to do, we're building a new deck. We'll say deck1.shuffle, console.log deck1.deck, and then let's do deck1.reset, and then console.log our deck1.deck. So we should see a shuffle deck and then a reset deck. Type error. This.deck.reset is not a function. Where am I writing that? Way up at the top. Oh. What's wrong here? It's not. This deck is an array. It's just this dot reset, right? Because I'm calling it on the deck class. The deck class knows about this deck, and that's what it uses to build it. So I'm calling this dot reset on the entire deck class, not the particular deck attribute. All right. So we run it again, and now we're getting one shuffled deck of cards, one unshuffled deck of cards. So those two behaviors are working for us, right? All right, what's the next one we need? We need deal a random card. So let's go into that. Let's build a new prototype. Deck.prototype.deal is a function. And what we're going to say is return this dot deck dot pop. We're just going to pop a card off of the top of it and give it back. Notice I'm not returning this for this function. I'm going to make it something that we can chain together on the player's side. The player can draw cards multiple times. The deck itself, once we pop a card off, I'm just going to give you that card itself. So deck.prototype.deal is just returning that removed card. It's a random card because our array is random. In fact, let's force it. Let's say this dot shuffle. Now when I'm creating a new deck, I'm getting back a shuffled deck every single time. So when I pop a card off, it's essentially a random card for me. And now that card is available and given to a player. Finally, deck should return the card that was dealt and remove it from the deck. We're essentially doing that in these two steps, right? We're popping the card off, the deck gets modified, it now only has 51 cards in it. Let's just make absolutely sure that it behaves like that. We'll say console.log deck1 dot, what did I call it, deal. Let's console log deck1 dot deal again. And then let's console log deck1 dot deck dot length. Ugh, gross. All right. So I'm getting the ace of spades, the three of spades. I like it. I'll bet on that. And I have 50 cards left. All right, so I got a pretty good poker hand, and I am, in fact, removing them from my deck. It's shrinking every single time. So I think we have the deck built. Let's build our player really quickly. So what do we want to call it? Var player equals function player. I'm letting other developers know I'm building a class. Players have this dot name equals name. Where does that name come in from? Right here, the object constructor. This is practically exactly like it was with Python, except we don't have a constructor method inside of it. Almost less steps even, right? Our player should have a hand. This dot hand is empty. Our player should be able to take a card and discard a card. So let's do take a card first. Where do we want to add this new method in the prototype? Player.prototype.draw is a function. How do we get access to our deck? We pass it in. So player.prototype.draw is expecting to receive a deck. The player does not have access to the deck because it is a different class. So from here, I can say this dot hand dot push deck dot, what did I call it? Draw. And it's going to draw that card and it's going to push it into my hand. And then I'm going to return this so I can chain it together. Oh yeah, deal. Sorry. Thank you. All right. So player.prototype.draw. So let's build a player really quickly. Var player1 is a new player, and that player's name is Brendan today. All right. I want to say player1.draw. I want to pass it deck1. I want to say player1.draw again. Pass it deck1. And then we'll say player1, or actually console log player1.hand. All right, so this is going to check multiple things. It's going to check that my name works. It's going to check that my hand works. And it's going to check that the draw is working how we want it. Let's run it. I have the ace of clubs, the 10 of hearts. I'm really lucky today. Let's go gamble. But it's also showing that it's working and the chaining is happening on the player side. So from the player, I can call and draw multiple cards, chaining them together, right? On the deck side, I'm just getting that object back because I'm popping it out.
So you should be able to spawn a deck 2 and then pull a card from this deck, right?
Yes, so let's try that. Var deck 2 equals a new deck. Now I can draw a card from both decks. So this has a very low chance of happening, but I could get the same card back. I got the 6 of hearts, the 10 of clubs. There goes my lucky streak. All right. So we can also pull from multiple decks. So if we need a card game that has the player, like it's Monopoly and we're drawing from different decks in the game, we can support that functionality. What's the last one we need is discard a card. I'm going to treat that pretty much the same as deal. I'm going to say player.prototype.discard is a function. And I think discarding the card, I almost want the card back that they're discarding. So I'm going to say this.hand.pop. And we're going to go ahead and just return that. So it'll remove the card off of the top of your hand. Now we might need to go in here and change this a little bit. That lets the players pick which card they discard. They'll need to put in some sort of index so we know which one it is, walk it to the end of the array, and then pop it off manually. I think we can all do that, but what I really want to show is let's do this in ES6 now. So I'm going to leave this here because I want to use it at the end, and we all know that it all works. But I'm going to just go ahead and comment it all out. And now we can see it in ES6. So what's the keyword I have now? Class. Does the deck, I always get this wrong. Does the deck have any inputs? Wait a second. Whoops. Oh, it's just mad at me for some reason. All right, so how do I pass parameters into an ES6 class? I have a constructor, right? So that constructor takes my input parameters. Does constructor have curly braces after it? I believe so. It's like a function call. All right, so inside the constructor, we have the same syntax. This.deck is equal to an empty array, right? Now this is where it gets different. Unlike the prototypes, we're going to attach these new methods inside the class definition. So what did we have as the first one? Reset. Reset is a function, and reset is going to behave exactly the same way, right? We can totally rewrite it. Let me just grab it and point out some things that are wrong with it now. It's filled with vars. Do we want to use the var keyword? What's the difference between let and var? What's a block? Curly brackets, right? Let lets us scope something to the block. So for an example of that really quickly, if true, else. This right here is a block. Everything in this if statement is a block. So if I use let x equals 10, I've scoped it just inside this side of the if else statement. This is where it gets hoisted to, this is where it's locked in. Var scopes it to a function call. In this case, this is making x global because it's not within any function call. In just about every case, let is more secure and safer than var. The moment we start writing in ES6, we just want to use let instead of var. It gives us more safety. Block scoping is how most variables work in most languages. And all of that crazy stuff about hoisting and balloons and anchors, all of that gets a lot easier because let doesn't make us make those mistakes. All right? So just keep that in mind. Let is your friend. So we want to use it. How many instances do we have? We have tons. This should be a let. 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 All right. Another thing I want to point out right here in this part of the code is reset is within my deck class. So I want to show you something about that really quick. So we're going to go back to that TypeScript interpreter that I was showing you this morning. The TypeScript playground, right? And I want to just take actually this class class deck with its constructor and its reset method. Actually, let's just go down here and hit this dot reset and call it officially. This is why talking about prototypes is so incredibly important. It's turning it into the exact same code that it was before, right? In fact, this code is a little bit weird in the sense that it's wrapping everything in an immediately invoked function first, but it's still doing the same behavior. It's creating the deck in one function call. It's creating the prototype outside of the deck definition, right? So when we're doing ES6, if we just code it as it was in Python almost, where we define a class, we define a constructor, and we define the methods of the class, we're getting all of the benefits we were getting when we were writing the methods outside of the definition and attaching it to the prototype. It is still behaving that same way at a low level. This is why I don't think ES6 is too magical. It makes the code better to write, it makes it easier to read in some cases, but it's not giving us anything that JavaScript didn't necessarily already have. And this is the big part of this demo. This is what I wanted to show people the most. It's the same code, right? Like almost I could have saved myself a ton of time by writing this first and then just pulling the raw prototype ES5 version out of Babel and just using that, right? So does this make sense, what ES6 is giving us? It changes how the interpreter looks at our code, but the code runs the same at a super low level. Awesome. I think that's all of like the fancy parts. We can make this look a lot cleaner. So for example, right here, we can use backticks, $, what did I want to call this? Suits at suit of $pips at pip. So I can use some ES6 string interpolation to clean this up a little bit. This string interpolation, the reason why it's so special is, what did I have to do before? I had plus signs and concatenation, and it's changing color on my editor back and forth, and it starts to look pretty wonky and weird. When this gets really huge and I'm like building a massive string out of your first name, your last name, your email address, you know, your date of birth, and all of this other information, and I'm like using the plus sign to concatenate it all together, this string interpolation ends up looking a lot more clean, and your text editor still shows it all as a string. So it makes it a lot easier to just read our code, right? So we're pushing that in, we're getting all the features we want there. So what would be the next thing? We can do shuffle and build that and attach it on. We can do deal and attach that onto the class, and we can do, what was the last one? I think that was the 3, reset, shuffle, and deal. All right, so does the difference between ES5 and ES6 make sense? Right? As long as we're on the same page as on that, we also need to know what's important about the prototype. So I want to just make one last comment about that, and then I want to release you all back in the wild. The prototype is one of the things that makes JavaScript run quickly, even though it's an interpreted language, and even though it's JavaScript. So we have your class, and let's say it's the car class. Your class has a prototype. Right? We can have tons of cars. And what they do is, when we call a prototype method, let's say .drive, we want to go back to this prototype and find the definition of that function there, right? And each of our cars, let's say our cars just have a color. So red, green, blue, black, light gray, whatever, right? So we have a car. There's one class in our code that exists. Our one class has one prototype. We could have thousands and millions of instances, but we're writing the definition of drive in just one place in memory. Even better, drive is not getting duplicated and attached to all of these different instances all at once. So When we use a prototype method, it is because we want to attach that method to every instance. If we want that method to be different on our instances, we should attach it to the constructor, so the constructor passes it to each instance. Every car needs to drive the same way. It would be a really weird interface if it wasn't built that way. However, every car listens to music differently. You might be plugging in your phone, you might be listening to the radio, you might be listening to a tape deck, right? So music is something that we would probably want to actually attach to every instance, because that's a method that's different depending on which car we're driving, right? The drive is the same instructions no matter what. So we're attaching it to the prototype. Instead of having 1 million instances of instructions on how to drive, we've gotten it down to just one. And even better, when we build a new car, we don't need to rewrite the manual from scratch anymore. That manual is already built. Instead of everybody getting a copy of everything that the car does, we're posting it on the internet in one place where everybody can go to it no matter where they are. One last important thing about this is if I add new methods to the prototype, like drive or honk, right? I can have instances already in existence that now suddenly have this new method. Kind of like when I attached isArray to the array class, I had arrays in my code already. Was it going to break them? No. Was it going to give them access to something new through the prototype? Yes. This is the important part about this prototype is this is how JavaScript does inheritance. It reaches into the prototype to find information about the class itself. It does not do inheritance like most other languages. It does what's called prototypal inheritance. I used to sit there and tell people that this was called prototypical because I can't read apparently. It literally says prototypal. Don't get that wrong in a Java review, you'll rewrite it. Okay? JavaScript uses prototypal inheritance. It uses the prototype to get access to the class, so each instance can actually gain that information. And through the prototype, we can actually start to see how we chain things together. So if we have a car class and we really want the top car class, we should extend it. Right? So remember, when we're talking about OOP in JavaScript, the story is a little bit different. We control it differently. And we're really getting away from that taxonomy tree, right? Where you have the car class, which inherits from the vehicle class, which inherits from the machine class, that inherits from the X class. It doesn't work like that. We have a car class, and we can pass in other instances into it, kind of like our car independent. So rather than a huge hierarchy, we can have the car class, right? And the car class takes 4 instances of the wheel class and 2 instances of the door class, and stores references to those instances within itself rather than extending the whole thing. Right? So this gets into some advanced JavaScript, but just keep it in mind. JavaScript OOP is a little bit different. It takes advantage of the prototype whenever possible, even if we write it in a way where we can't necessarily see the prototype anymore. I promise you, it's there, hidden under your code. There is always a prototype, and we're always accessing it, and we're always attaching methods to it. Anyway, the most important assignments, I think, are Ninja 1 and Ninja 3, because it has us extending the classes a little bit. It has us writing a proper ES6. It has a little bit of public and private. I don't really mind if you don't understand public and private. For a front-end scripting language, we don't really get privacy to begin with. We're sending our code here to the client. They can see the whole thing. But I want to see Ninja 1 and Ninja 3 done. Deck of cards, especially if you don't have it yet, try and get it implemented. If you're stuck on it, just let me know. We'll kind of move on to the next step. If you are moving into advanced, the only assignment I actually care about in advanced is the underscore library. I think it's called JavaScript library. If you could do that one, you get an intro onto callbacks, which I want to talk about promptly tomorrow morning. And let me end this recording and you guys are watched.